I hope everybody's doing well. This is going to be the homework solutions for section 7.5 that I promised. I think there are roughly 7 questions. I might have said 5 in class, but I put a couple easy ones on here as well, just so we can get used to seeing how this stuff works. So for the first one, this is just straight up a proportion. All right, so we're going to simply just cross multiply. And the key to this is to kind of just like write out the cross multiplication first without actually multiplying, just to make sure you're writing out properly and you're distributing everything as well. So cross multiply, so we get 8 times the quantity n plus 10 equals 2 times the quantity 90 minus n. And then from here, we just go ahead and distribute. So we get 8n plus 80 equals 180 minus 2n. Then we're gonna, let's see, we'll get the like terms together. So we'll add 2n to both sides. That's gonna give 10n plus 80 equals 180. Finally, subtract 80 from both sides. 10n equals 100. And then finally, divide both sides by 10 to give me n equals 10. And that's how you do the first one. So now we're going to do question number 2. So let me just paste that in here. And it doesn't look the greatest, but you should have this uploaded, or at least on your screen. So we'll go through it together. So a veterinarian prescribed Sunny, a 63-pound dog, an antibacterial medicine in case of an infection that emerges after her teeth were cleaned. If the dosage is 5 milligrams for every pound, how much medicine in milligrams was Sunny given? So once again, we have a rational expression, and in this case, it's going to be another proportion. And the key to this problem is right here. Because we know that for every 5 milligrams for every 1 pound. So that's a ratio right there. So if I just zoom out here a little bit, we got our equal sign. And it doesn't matter, like I said, it doesn't matter how you set this up. What matters is that you write the proportion out properly. So on the left-hand side, I'm just going to write 5 milligrams per 1 pound. And that automatically means on the right-hand side, the units are going to match as well. Okay, so what's going to go on the right-hand side? Well, it's going to be the weight of Sunny, our dog. So that's going to be 60 pounds or 63 pounds. And therefore, X, which is the amount of medicine that we're trying to find, the vet is going to give her. So we cross multiply again. And that's going to give us 5 times 63 equals X. And just remember, X is going to be in milligrams. So all we have to do is take 5 times 63, and I'm doing this off screen on my calculator to give us 315 milligrams, which is going to equal X. So that's how much medicine Sunny is going to get. All right, let's do question 3 now. Question 3 is another straightforward one. So 1 ounce, one 12-ounce can of soda has 150 calories. Right there's our ratio. So if we want to, we can immediately just go 12-ounce can. So 12 ounce over 150 calories. We already know what this ratio over here is going to look like as well. They got to be the same because you have an equal sign. So if Josiah drinks a 24-ounce can from the local mini mart, how many calories does he get? So 24 over X. Let's go ahead, cross multiply. So we get 12X equals 24 times 150. To keep our math simple, let's go ahead, let's multiply. 24 times 150 yields us 3,600. And finally, divide both sides by 12 to give me x equals 300 calories. That is one high caloric drink. Good luck burning those calories, Josiah. Anyways, all right, we're gonna let's go ahead. Let's look at the next problem. All right, so I kind of did some editing here so we can see the problem instead of like the previous one. So Mary takes a sightseeing tour on a helicopter that can fly 486 miles against a 25-mile-per-hour headwind in the same amount of time. It can travel 666 miles with a 25-mile-per-hour tailwind. So let's find the speed in miles per hour of the helicopter. So this is one of the problems that we looked at in class. All right, same exact setup. It's just instead of being, we were in an airplane in class. Now we're in a helicopter, but the idea is still the same. So you have a headwind, and then you have. Oh, I got these backwards. Maybe if I draw like a helicopter. How do you draw a helicopter? Does it look like this? There we go. There's our helicopter right there. So this would be the tailwind. Now it makes a lot more sense. And this would be our headwind. So the tailwind works with us. And then the headwind works against us. So the best thing to do, all right, is to remember two things. First, your distance equals rate multiplied by time, formula, and a table, okay? So the table is really kind of easy to set up. We'll do tailwind first. We're going to do headwind second. And then across the top, we're going to do I'll do it like the book does it in case you're looking at the book. It does distance on the far right-hand side. And then over here we have our rate. And then we have our time. And finally, what we can do is start labeling things. Okay, so we know the helicopter flew 486 miles against the 25-mile-per-hour headwind. So 486 goes here. And the rate is going to be R minus 25 because we're working against, so it's actually pushing against us. For the tailwind, 666 miles, and we're doing that with a tailwind. So R plus 25. Now, when we look at the formula that we have right here, the key to this entire situation here is that it took the same amount of time to travel in either direction, okay? So because of that, we can solve this formula specifically for time. So I'm going to write it in red. Time is going to equal distance over the rate. And the reason why we do this is because remember, time up has to equal time back. All right. In other words, this helicopter went somewhere and then it came back. So the time is going to be the same. It's just that the distance that it traveled is going to be different because you're working with the wind or against the wind. So all we have to do to finish our table is to look at our table and say, well, for time with the wind or with tailwind, it's going to be 666 over R plus 25 because it's distance divided by rate. And then the same will be below, except it'll be 486 over R minus 25. Okay? And finally, we can go ahead and solve our proportion because these two things are equal to each other. So 666 over R plus 25 is going to equal 486 over R minus 25. And now we have a nice proportion. So we're going to cross multiply. 666 times r minus 25 equals 486 times r plus 25. I'm going to go ahead and distribute. So we get 666r minus, and that's going to be 16,650 equals 486r plus, and like I said, I'm just doing this off screen on my calculator, 12,150. Let's go ahead, let's get the r's together so we can subtract from both sides of the equation. We get 180r minus 16,650 equals 12,150. Now we're going to add 16,650 to both sides. So give me a second here. 16650 plus 12150. And that's going to be 28,800. And finally, divide both sides by 180 to give us a very nice number of 160. Okay, and that is, what is that? Feet per second, miles per hour, miles per hour. All right. Now, the thing we have to remember is this is how fast we would be moving in still air, meaning there's no wind. However, we have wind. So in purple, our tailwind is going to be 160 plus 25, which is 185 miles per hour. Oops. Then our headwind is going to be 180 minus 25, which turns out to be 155 miles per hour. Okay? All right then. Let's get ready for the next one. Okay. So in this scenario, very similar question, except this time we're in a speedboat. So Jim's speedboat can travel 19 miles upstream against a 3 mile per hour current in the same amount of time. That sounds familiar. It travels 21 miles per hour, or I'm sorry, 21 miles downstream with a 3 mile per hour current. Find the speed in miles per hour. So we just want the speed of the boat. That's it. So if we remember about the previous problem, we're going to set this one up the same way. Okay. So we got upstream. And then we have downstream. All right. Then we have our rate, time, and distance. And we know Jim's boat can travel 19 miles upstream against a 3 mile per hour current. So that's going to be R minus 3. And then it can travel 21 miles downstream with a 3 mile per hour current. So same exact problem. We know time will equal distance over rate. So I'm going to zoom in. So I have more space to write this. In fact, I'm going to shrink my pen down a little bit here. So we have 19 over r minus 3 and 21 over r plus 3. All right. From here, we're going to set up our proportion. So we have, I'm going to use my black marker now. So we have 19 over r minus 3 equals 21 over r plus 3. Let's do our cross multiplication here. 19 times the quantity r plus 3 equals 21 times the quantity r minus 3. That gives me 19r plus 19 times 3 is 57. And then 21R minus 63. From here, let's get our r's together. So I'll subtract 19r from both sides. It's going to give me 57 equals 2r. Let me just double check just to make sure. Minus 63. We add 63 to both sides. Gives me 2r equals 57 plus 63 is 120. Finally, divide both sides by 2, which gives us 60. Let me write that nicer. So the boat is moving 60 miles per hour, which is a really good definition of a speedboat. All right, so I'm going to scroll up and get ready for the next problem here. All right, now this problem is definitely complex. So let's take our time with it. Hudson travels 1,080 miles in a jet and then 240 miles by car to get to a business meeting. The jet goes 300 miles per hour faster than the rate of the car, and the car ride takes 1 hour longer than the jet. What is the speed in miles per hour of the car? Now, notice in this question, it didn't say anything about like, it took the same amount of time to get to these places or anything like that. All right. So we need to think about, okay, what's happening here? So what we definitely know, okay, is we have a jet ride and we have a car ride. So we have two different, so Hudson is doing two different things. All right. We also know the car ride is 1 hour longer than the jet ride. Okay. So remember, anytime you see the word is in math, you know you got an equal sign here. Okay. So the only thing that we really need to have to figure out here then is, well, how long did it take for the jet ride? How long did it take for the car ride? All right. So the easier of the two right now, all right, is going to be the jet ride. All right. And the reason for that is we know the distance traveled. So, you know what? Let me go down here. We'll come back to this thing in a second. I'm going to put a star next to it. Okay. We'll come back to this. So we know in our jet ride, according to the problem, all right, it was 1,800 miles in a jet. Let's see here. Oh, and the jet goes 300 miles per hour faster than the car. All right. So if we remember, distance equals rate multiplied by time. Okay. Then we know time is going to equal d over r again. So we have 1080 over, let's go r plus 300. Because if we know the rate of the car, we know that the jet goes 300 miles per hour faster than that. All right, so here's our jet ride. Okay, the car ride. All right, let's go back and look at the car. So the car says, hey, the car goes 240 miles by the car to get to the business meeting. Notice it doesn't say anything about how fast the car is going. So our car ride is going to be 240 over r. All right, so far we're starting to look a little bit good here. Okay, we're starting to look good. However, there's one thing that we need to consider. Okay, and that one thing we need to consider here is the fact that, and this is where we come back up to that star, the car ride is 1 hour longer than the jet. All right, so our car ride is going to be, our car ride is going to be whatever the jet ride was, or the jet time, plus 1 hour. All right, so this is the car ride time. So now, oops, sorry, I used the letter X. Should have used R. So here we have our two equations that we're going to set equal to each other. All right, so we have 240 over R equals 1080 over r plus 300 plus 1. All right. And from here, you have many different ways you can do this. All right. Traditionally, we would find the LCD. We would, let me see here. What's the next thing we do? Oh, yeah, reduce all denominators. All right. And then we would solve appropriately. All right. Which is fine. You can still do that. But what I'm going to do is I'm going to, excuse me, I'm going to cross multiply because we've been doing it the whole time. All right. So to cross multiply, so let me erase this real fast. So to cross multiply, remember you need a fraction equal to another fraction. So we have a fraction here. We have a fraction here. But then we have this plus 1. So what can we do with that? Well, the reason why I'm doing this using proportions is because this is a plus 1, and it makes our life a little bit easier. All right, so watch what I do here. If I want to make one fraction out of the right-hand side, I have to add these two things together. I got to add these two things together here. And that's exactly what I'm going to do. So underneath, I'm going to write 240 over r equals 1080 over r plus 300 plus r plus 300 over r plus 300. Because notice, that's 1. So then I can rewrite my problem as 240 over r equals 1080 plus, r plus 300 over r plus 300. And yes, we are going to group those two things together there. So that's going to give me 240 over r equals, let's see here, 1080 plus 300 is 1380 plus r over r plus 300. And notice we have a fraction equal to a fraction. So we're going to have to cross multiply this. All right. So let's go ahead and do that. Remember, write it out first and then go ahead and do your multiplication. So we get 240 times r plus 300 equals r times 1380 plus r. Now we distribute. We get 240r plus, let's see here, 300 times 240 is 72,000 equals 1380r plus r to the second. And yes, alarm bells should be ringing. And why? Look at that exponent right there. That is something squared, which means we have to set this equal to 0, factor, and then zero product property. So how can we do this here? What's the easiest way? Well, since this is already positive r right here, let's move everything over to the right-hand side. All right, so we'll do this step by step. I'm just going to rewrite it. All right, so the first thing, let's get those r's together. I keep saying r, I feel like a pirate. So we get 72,000 equals 1380 minus 240 is 1140r plus r to the second, and then subtract 72,000 from both sides. And I'm going to write this in descending degree. So we get r to the second plus 1,140r minus 72,000. And from here, I'm going to factor. And this does factor very nicely. It factors into r plus 1,200 times the quantity r minus 60. So we can set each one of these equal to 0. Solve appropriately. So for the first, r equals negative 1,200. For the second, R equals 60. Now, mathematically, these are the answers. However, rate can't be negative. So this is extraneous. And our final answer is R equals 60. Okay, so I hope this makes sense. It was a little bit different from what we're used to because of the +1 thing. Okay, now we have one more problem. So let's go ahead and get set up for that. All right, so Byron wanted to try out different watercrafts. He went 21 miles downstream in a motorboat and 57 miles downstream on a jet ski. His speed on the jet ski was 20 miles per hour faster than in the motorboat. Byron spent a total of 4 hours on the water. What is his rate of speed in miles per hour of the boat? All right, now here's the thing. Okay, every single one of these word problems. All right, especially let's go back. We'll go all the way back to the first one because the first one had the picture. Here it is right here. Okay, every single one of these word problems, something was working with us and then something was working against us, correct? And this word problem, I want you to look and read it one more time with me. Okay. So in this situation, Byron, he wanted to try out a different watercraft. So he went 21 miles downstream in a motorboat and then 57 miles downstream on a jet ski. So Byron is not, there's nothing working against him. In fact, it's working with him. So 21 miles downstream. And this is going to be the motorboat. And 57 miles downstream on the jet ski. Okay? So whenever like you have a situation like this, I mean, and just look how this is going here. We have two different things, but they're connected and they're going in the same direction. So we're going to add these two things together. Okay? And we know that regardless of regardless of the watercraft, he was on the water for a total of 4 hours. Like we know that. Okay? So if you look here, all right, we basically have an equation set up. We have our distance over our rate for each one of these. We have it for the motorboat, and then we also have it for the jet ski. So all we have to do here is just kind of figure out, okay, what does the motorboat look like? What does the jet ski look like? Add these two things together. So you know what? I'm going to erase the word at and put an addition sign and just solve. So it's actually not as hard as what you think if you just think about what's happening. And I try to emphasize that all the time. Put yourself in a situation and ask yourself what is happening. No math whatsoever. Okay. So let's go ahead. We'll go left to right. So the motorboat, well, we have no idea how fast this motorboat goes. All right. So that's going to be 21 over X. Okay. Now, for the jet ski, well, we do have a little idea because the jet ski said his speed on the jet ski was 20 miles per hour faster than the motorboat. So that's his speed. So we know he went 57 miles. But then the rate is X plus 20. And this is going to equal 4. All right, so there's our problem. Now, for this scenario here, I would just go ahead and do this the traditional way. All right. So our LCD, I'll do it off to the right here. The LCD, well, that's just going to be just the multiplication of the denominators that we have. So I'm going to go ahead and multiply each one of these. By X times the quantity, X plus 20. So I'm just going to write this out here. All right. Then I'll highlight what I'm going to simplify first. So going from left to right, I will simplify the x's. So let's go ahead and do that. We're left over with 21 times the quantity x plus 20 plus, for the middle, we're going to simplify the x plus 20s. So let's go ahead, let's do that. That's going to give me 57x equals, and I'm just going to leave this the same for now. Nothing reduces on the far right side. All right, now let's go ahead, let's distribute. So we're going to get 21x plus 21 times 20 is 420 plus 57x equals 4x to the second plus 80x. Again, right here, we see this. This is not, I don't want to say it's a red flag, but this is telling me set equation equal to 0, factor 0, product property. All right, like that's what it's telling me to do, because that right now is the highest degree, and that is going to dictate what technique I use. So let's go ahead, let's group like terms. 21 plus 57 is going to be 78x plus 420 equals 4x to the second plus 80x. Now we're going to get this equal to 0, so let's subtract 78x from both sides. Well, that gives me 420 equals 4x to the second plus 2x. And finally, subtract 420 from both sides. And that gives me 0 equals 4x to the second plus 2x minus 420. And before I do anything, I see that I have a GCF of 2. So that's going to give me 2x to the second plus x minus 210. Now, for those of you wondering, does this factor? The answer is absolutely it does. You're going to have to use the AC method, but if you factor correctly, you're going to get the quantity of x minus 10 times 2x plus 21. Okay? So remember, the zero product property says only take the factors that contain a variable and set them equal to 0. So we have x minus 10 equals 0. And then we have 2x plus 21 equals 0. So we solve each one of these by, first, we're going to add 10 to both sides. That gives me x equals 10. Second, I will subtract 21 from both sides to give me negative 21, and then divide both sides by 2 to give me x equals negative 21 over 2. Now, from here, once again, common sense has to kick in, okay? We cannot have a negative speed, all right? So the only solution is x equals 10. So the question, and I completely forgot what it asked. It asked for what is his rate of speed in miles per hour of the motorboat. So he was traveling 10 miles per hour in the motorboat. All right. And make sure that's correct here. Yep, the motorboat. Okay, good enough. Just making sure. And that's it. So I hope you found this video to be at least beneficial. You will have one of these types of problems on the test. And what I mean by types of problems, it's any one of these on the test. All right. So I will basically pick one of these scenarios, throw it on the test, and expect you to know how to do it. Good luck, and I will see you in the next one.